Welcome back, bio students. This is the next lecture in our journey through Bio A at Fruitport High School. Chapter 2 focuses on the chemistry of biology, with our first unit focusing on the properties of the water molecule. So by the time you're done with this, we would like you to understand, we would like you to be able to describe the different properties of water, how water is used as a universal solvent, what the polarity of water is, and some of the things that water is used for in living organisms. So the water molecule is just that. It's a molecule, and the water molecule is neutral. Even though we say the molecule is neutral, it does have a slightly negative charged end and a slightly positive charged end. The oxygen side of the molecule, and this is where the chemistry comes into play, the oxygen side has a slightly negative charge, and the hydrogen side has a slightly positive charge. And that just has to do with how strong the electrons are being shared within that water molecule. Because of this difference in charge, because it has a positive and a negative end, we refer to the water molecule as being a polar molecule. And what you'll see as we go through this lecture is the polarity of that molecule helps it to break down many different substances. So here's a diagram of the water molecule. You can see the larger oxygen atom surrounded by two hydrogen atoms. That's where we get the H2O from. The oxygen has a slightly negative charge up here, and the hydrogen has a slightly positive charge at this end. So because we can split that in half down the middle, and one side's negative and one side's positive, we call the water molecule a polar molecule. Hydrogen bonds help to hold the molecules together. So water, if you placed water on a piece of aluminum foil or a piece of wax paper, and you get the water close enough together, the water actually grabs onto other water molecules. It's attracted well to those other molecules because of the opposite charges attracting, and that hydrogen bond pulling the water molecules together. Now, with water, we can talk about solutions and suspensions and also mixtures. So if you go back to physical science, a little review from physical science, mixtures are composed of two or more elements or compounds that are physically mixed, but not chemically combined. In other words, we can separate them with simple physical means. Salt and water, if stirred together, mixed together, is a mixture or a salt water solution. Kool-Aid in water is a solution. These things can also suspend other particles, and you'll see how these solutions and suspensions, the examples we give you with living things. Okay, so solutions, if the components of the solution are evenly distributed, so if they look the same throughout, it is a solution. That's a solution mixture. In salt and water, there's two different parts to that, but salt and water is a saltwater solution. In a saltwater solution, the table salt is the solute. The solute, remember, is the part that's being dissolved. In the saltwater solution, the water is the solvent. And solvent, remember, is the substance which is doing the dissolving. So again, a couple of key vocab words here. Solution looks the same throughout. All parts are evenly mixed. There's a solute and a solvent in solutions. The solute is the part that's actually being dissolved, and the solvent is the part that's doing the dissolving. Here's a diagram when you place salt in water, a crystal of table salt placed in warm water, the sodium and chlorine ions are attracted to the polar water molecule. Sodium has a positive charge, chlorine has a negative charge, and because of those opposite charges, they're attracted to the positive and negative ends of the water. The ions break away from the crystal and are surrounded by the water molecules. This allows the water to dissolve them, and the ions gradually become more dispersed in the water, forming a saltwater solution. Now, because we said it's not a chemical change, you can actually physically separate the salt in the water by letting it sit. Once the water evaporates, it'll leave the salt ions or the salt crystals behind. So water's polarity, remember we talked about water being a polar molecule. Water's polarity gives it the ability to dissolve both ionic and other polar molecules, such as sugar. We call water the universal solvent. Easily dissolves many different things on Earth. And to see how quickly it dissolves, turn your faucet onto hot water and place a plate of leftover spaghetti sauce underneath it, and it will dissolve and rinse the water very well. Warmer water dissolves usually much quicker than colder water. If you mix hot chocolate, you use hot water or hot milk. If you try to use cold water, the hot chocolate does not dissolve as easily into the water. You've got to do a lot more stirring. Okay, suspensions are materials that do not dissolve when placed in water, but they separate into pieces, so small that they don't settle out. The movement of the water molecules keeps the small particles suspended. And then such mixtures of water and non-dissolved materials, those are called suspensions. So in biology, some of the most important fluids in biology are both solutions and suspensions. The blood that circulates through your body is mostly water, and it contains many dissolved compounds, including salt. Blood also contains cells and other undissolved particles that remain in suspension as the blood moves through the body. So blood is both a solution and a suspension in the way that it breaks things down and the way that it carries things throughout the body. And that is it for the lecture on water molecules. I will see you next time in class.